Hello everyone, my name is Ahmed Abdel Latif. Today I'm presenting our work that use bots on the top of software repositories to answer developers' questions. This work was done with my colleague Khaled Badran and under supervision of Dr. Imad Shihab. Software repositories contain a large amount of data that can help to improve the quality of the software development process. However, previous studies show that extracting useful information from these repositories remains to be a difficult task. Why is that? This is because that some of the information requires that users navigate through a lot of data to find the answer. Moreover, in some cases, information needs to be extracted and linked from different sources to retrieve the answer. So extracting useful information is considered to be challenging. This is because of the lack of tools to support the data extraction from the repositories. Also, in many cases, project stakeholders need special expertise to mine their repositories. And even if the stakeholder has the expertise to perform such a task, it requires a dedicated effort and time. To overcome those challenges, we present an approach of how bots can be layered on the top of software repositories and used to answer some of the most common software development and maintenance questions that face developers. Here is a snapshot of a developer chatting with the MSRBot on Slack, where at first the developer greets the MSRBot and then asks about who created a certain file in the project, which is in this case Kafka admin client.java. And here the MSRBot replies with the name of the developer who created the file. Finally, the bot is asked to find the developer that fixed most of the bugs in that file. Say in the case you find an issue in the file and want to find the developers with the most experience to deal with it. The MSRBot here replies with the name of the top 5 developers who fixed the most bugs. To evaluate our MSRBot framework, we devised 3 research questions. First, we need to evaluate whether the answer returned by the MSRBot is useful in answering the participant's question. Since the bots are meant to answer the question in a chat-like form, speed is of the essence. Therefore, in the second research question, we measure the user's speed while performing tasks related to their repositories using the MSRBot. And finally, it's critical that the MSRBot returns accurate results as software practitioners generally act on this information, sometimes derive major tasks. So we evaluate the accuracy for the bot. To answer our research questions, we constructed a case study. First, we surveyed our work that investigate the most commonly asked question for software practitioners. Next, we developed the MSRBot to answer those 15 questions. Then we applied the MSRBot on Hibernate and Kafka software projects, which have more than 100 releases and more than 6,000 commits and issues. And finally, we asked 12 developers to perform 10 tasks that formulated from the 10 randomly selected questions, once while using the MSRBot and another without using it, where we call it baseline. The results of our first research question show that on a Likert scale, most of the developers found that the MSRBot is either useful or very useful. On the other hand, 10% of the developers said that some information is missing in the bot's answer, such as commit hash. As for the second research question, we measure the task completion time and find that the approach of using the bot takes significantly less time than the baseline approach, whether we are considering all tasks completed and uncompleted or only the completed ones. Finally, we evaluate the accuracy of the MSRBot because it's critical that the bot returns correct results. The results show that the MSRBot achieves an accuracy of 90% in answering the user's question, which is higher than the baseline accuracy of 25%. Next, we did a follow-up interview with the developers to understand what they felt were the strengths and areas for improvement for the MSRBot. One of the participants pointed out the ability of the bot to provide answers from a rich history very quickly. Another participant suggested that a clear improvement is to support more questions. And one of the participants recommended to allow the user to dive more into the bot's result as a potential future feature. While building the MSRBot, we were faced with many challenges, which we think also apply to many other software chatbot that operates on the top of software repositories. So first, we needed to carefully select the best natural language understanding platform that operate based on the software engineering domain. This is because it affects the chatbot ability to understand the user's question. In our case, we use Google Dialogflow. Another challenge we faced was the lack of software chatbot training data. So we had to generate our own by piloting the bot with real developers. And finally, we need to expect the user behaviors and maintain the conversation flow at all times. To conclude our presentation, we present our motivation, then we explain our approach and case study and present our results. And finally, we present the challenges that face us while developing the MSRBot. Thank you for your listening.